Hello, welcome. Let's try to solve the code problem 112, path sum. So for this problem, we are giving the root of binary tree, and we are also giving an integer variable target sum. So for the first example, the target sum is 22, and we just need to find a path. If this path sum of if the path sum equal to the target value, so it's gonna be a true. If we didn't find such cases, we're gonna return false. So for example, 4, 5, 11, 2. So the sum of them is going to be 22, and this is a path, so we're going to return true. For the second example, the target sum is 5. So 1 plus 2, 3, 1 plus 3, 4. There's no such target sum, so we're going to return a false. Yeah, if there's nothing inside, so the target sum is 0, because there's nothing inside, so we're going to return a false. Yeah. And the number of nodes is 5 times 10 to the power 3, 5,000, so this is okay if we solve it by using on time. So I'm going to define a DFS function. Actually, this is just a pre-order traversal. So inside I'm going to call the root and target sum. Yeah. Now let me just write the DFS. So it's going to be a Boolean value, and this is going to be a DFS. So inside it's going to be a tree node. I'm going to define it as a node. Here I'm going to define an integer as pre. Yeah. As I pass the target sum to this tree, so this means for my condition, if I traverse the tree, if I go to some node, maybe for this node 2, if the target sum also equals to 2, so it's going to be true, because from the beginning this target sum is going to be 22. So 22 minus 5 minus 4 minus 11. If currently, if I traverse it to this node 2, the target sum also equal to 2. This means I've already found it, because this 2 is also a leaf node. A leaf node of the tree. This means it is right. But if it is not a leaf node, it is not okay. Yeah. So this is just the condition to check. Yeah. So if node equal to none, I'm gonna give a false. So this is for the situation like 5, 8 to 13, and the node then becomes none, and I didn't find it. I didn't find the target sum, so I'm gonna return false at here. Yeah. But if node dot left equal to none, so this means node is not equal to none. But if it is left equal to none, and it's right equal to none, yeah. So this means this node is a leaf node. So I can return if this node dot value equal to the pre. So pre is my target sum. If it is equal to pre, it's going to be true. Otherwise, it's going to be false. Then I just need to call the recursive function. Actually, this is just a pre-order traversal. So I'm going to call it. I want to go to the left side. If I go to the left side, what happens for this pre? So the pre gonna minus the value. And similarly, it can also go to the left side and the right side. Yeah. So for either way, if I find a path sum, it's gonna be true. Otherwise, it's gonna be false. This is why this from here it is all. So from here, it's gonna be node dot right and pre minus node dot value. Yeah. Now let me just run it to check if it is okay. As you can see, it works. Now let me just submit it to check. Yeah, as you can see, it works and it's pretty fast, and the time complexity is OA. Yeah. So the basic idea is that we just need to use a pre-order traversal. So the pre-order traversal is that we're gonna first check the root node, and then we're gonna go to the left and go to the right. While we find a node which is a leaf node, we need to check the value. If this value equal to the target sum, equal to the pre, it's going to be true. Otherwise, it's going to be false. So if I didn't find it, so for example, from this 5, I didn't find it, I'm going to recursively go to the left and go to the right side until I find it. So I think it's all about it. Thanks for watching.